Welcome again to this presentation. Today we are discussing the question and the answers regarding the solubility equilibrium. Let's start on question number 1. Question number 1 is saying calculate the solubility product of lead sulfate solution if 3.03 times 10 to the power negative 2 grams of the product is dissolved in 1 liter of water at 25 degrees Celsius. Here we need to calculate the solubility product of lead sulfate. So we have the mass of the product and also we have the volume. The volume is 1000 milliliter or 1 liter, and the temperature was given. And as you remember, if you are calculating the solubility product, we need to calculate it from the concentration of ions. So we need to find the concentration of lead and the concentration of sulfate. And from here, we can determine the moles, and from the volume, we can determine the concentration by taking the moles over the volume. Let's quickly go to the answer. So we need to determine the molar mass of lead sulfate is this one, 303 grams per mole. Then we determine the number of mole. That means we take the mass dividing with the molar mass. The mass was given. Then we divide with the molar mass to find the number of mole. Then after getting the moles, we can determine the solubility or the concentration, which is equal to number of mole dividing with the volume. The volume here, 1000 milliliter. That is where you have to convert to 1 liter. So 1000 milliliter is equal to 1 liter. Then you have this concentration or this number of mole per liter. Then as you can see, lead sulfate, we have only 1 mole of lead and 1 mole of sulfate. Lead sulfate will produce lead 1 ions, 1 mole of lead 2 plus and 1 mole of sulfate 2 minus. That means the concentration of lead will be equal to the concentration of sulfate. The moles of lead will be equal to the moles of sulfate. Then here, if we assume that the concentration of lead is S, or the solubility of lead is S, that means also the solubility of sulfate will be S. Then we have the KSP, which is equal to S times S. Because here we have 1 mole and we have 1 mole, and all of them they are in 1 liter, in the same container, in the same volume. So that means if now we assume that the solubility of lead is S, or the concentration of lead is S, that means this will be S and the sulfate also will be S. Then we have the S square. Then we have the KSP, which is equal to S square. That means S square is equal to KSP. The KSP, it was given. So here, then we get 1.19 times 10 to the power negative 8. So we obtain the KSP from multiplying the individual ion. So here we have the lead and here we have sulfate. And then if we have this concentration of lead sulfate, that means we have this concentration of lead. We have also this concentration of sulfate. Then if you multiply this one, that means this one is square. Because this one multiply with this one is also we get this one is square. Then we have this KSP is equal to 1.19 times 10 to the power negative 8. Hope that is clear. When you are determining the solubility product, you need to multiply the individual ions. KSP, here we have the S, which is the concentration of the lead. Here we have also the S, which is equal to the concentration of sulfate. Then we get the S square because of them they are equal. Then we have this one because the concentration of lead sulfate, we have it, that will be equal. This concentration also, lead sulfate is equal to the concentration of lead, is equal to the concentration of sulfate. Let's go to question number 2. Question number 2 is saying the solubility of barium sulfate is this one. The solubility was given in gram per 100 milliliter solution. Then they are saying to calculate the KSP. Here we have the solubility in gram per 100 ml. We need to convert in mole per liter. That means to convert the solubility in mole per liter, we need to change the mass. The gram here, we change to mole, and here the volume 100 ml, we change to liters. So in this case, we have the solubility gram in 100 ml solution. To obtain mole per liter, we change this gram to mole by dividing with the molar mass, and also we change the volume to liter. We have the molar mass of barium sulfate, which is equal to 33 gram per mole. Then we need to determine the mole of solute by taking the mass, dividing with the molar mass. We get this number of mole. Then that means we convert this one to liter. That means we divide with 1,000, we get 0.1. Then the solubility will be equal to mole per liter. So we take the moles dividing with liter. Then we get 1.03 times 10 power negative 5 mole. This is the solubility of barium sulfate. That means the concentration of barium will be equal to the concentration of barium sulfate. The concentration of sulfate will be equal to the concentration of barium sulfate. That means here also, if we are determining the KSP, we need to multiply the concentration of barium times the concentration of sulfate, which is equal to this one. So then the KSP will be equal to S times S, which is equal to S squared. It's the same as taking this one squared. That then we get 1.06 times 10 power negative 10. So that means we are putting S times S because the solubility of barium is equal to the solubility of sulfate. If we are multiplying the two, then you get S squared. We are doing this because if you check barium sulfate is 1 mole, we produce 1 mole of barium and 1 mole of sulfate. That means the concentration of barium sulfate will be equal to the concentration of barium. It will be also equal to the concentration of sulfate. Let's move to question number 3. Number 3 is saying calculate the solubility of calcium sulfate in water in mole per liter, in gram per liter, in gram per 100 ml, and in gram per 100 gram. Assume that the volume occupied by the solid in the solution is negligible small. So the KSP for calcium sulfate was given. Now they want us to calculate the solubility in mole per liter, in gram per liter, in gram per 100 ml, and in gram per gram. So here, as long as we have the KSP, we can determine the solubility of calcium sulfate. Let's see the formula for calcium sulfate is this one. That means the KSP is equal to calcium concentration times the sulfate concentration. Of course, they will be equal because calcium sulfate, when it is dissociating, will give the 1 mole of calcium and 1 mole of sulfate. That means this one will be equal to this one. Then we can replace as X or S. So that means we get the KSP, which is equal to S squared. So we are replacing the KSP equal to here S and also this S. Then we get the S squared. Then we determine the S because the KSP was given as 2.4 times 10 power negative 5. So we determine the solubility in mole per liter. So that means here, that's what they are asking, the solubility in mole per liter. What will be the solubility in gram per liter? That means we need to change here mole to gram by multiplying with the molar mass. The molar mass of calcium sulfate is 136.14. Here then we have this one. We take this mole times the molar mass. Then we get the mass. We get 0.67 gram per liter. Then how do you convert to gram per 100 ml? That means this gram they are in 1 liter. Then how many gram will be in 100 ml? We need to divide by 10. Then you get 0.067 gram per 100 ml because this is the gram in 1 liter. Then in 100 ml, in this case, we divide by 10. We obtain 0.067 gram per 100 ml. How do you get gram per 100 gram? That means you need to convert this one to gram by using the density. So in this case, here, considering the solvent to be water, water is having the density which is equal to 1 gram per milliliter. If you are multiplying this 100 ml times 1 gram per milliliter, then you get 100 grams. So that means also here the 100 milliliter is equal to 100 grams. So that means the solubility in gram per 100 gram will be equal to 0.0767 gram per 100 gram because we have the water and the water is having the density of 1. That means 100 ml is equal to 100 grams. That applies only for water because water is having the density of 1. It is not applying to all the substances. Let's go to question number 4. Question 4 is saying determine the solubility of silver chromate, ferric hydroxide, and mercurous iodide at this temperature. Determine also the molarity of individual ions. KSP for silver chromate was given. KSP for ferric hydroxide was given, and the KSP for mercurous iodide was given. So what you need to determine is determine the solubility and also determine the molarity or the concentration of each ion. So as long as we have the KSP, we need to check the ion. So for example, silver chromate, this is the formula for silver. Upon dissociation, it will give 2 moles of silver. That means the concentration of silver will be double the concentration of silver chromate. It will give 1 mole of chromate. So here also, that means the concentration of silver will be double the concentration of chromate. So the KSB will be equal to silver, because here we have 2 more. We need to have a 2 square here. We need to square this 2 here, then times the concentration of chromate. If you are supposing the concentration of chromium ion as S, if this one is S, that means this one will be 2S, because here we have 2 moles. If this concentration of chromium is S, that means the silver will be 2S, because here we have 2 moles of silver which will be produced. Then if you are replacing, we have the KSP. Here we put 2S, because the concentration here will be 2S, then times S. So also here we have 2 square. Then we get this value, KSP is equal to 4S power 3. Then this one we have it. We are replacing the KSP for silver chromate. It was given. After then replacing the KSP for silver chromate, then we determine the S, which is the solubility of the ions, the solubility of silver chromate. Then if you continue, we see that we have the answer, which is equal to 6.5 times 10 power negative 5 as the solubility of this chromate. But to obtain the solubility for the concentration of the silver, that means you need to take this one multiplied by 2. So that means for chromate, it will be equal to this one. But for silver, we need to multiply by 2, and then you get 1.3 times 10 power negative 4 molar. Then let's go to ferric hydroxide. It's the same. Can you see ferric hydroxide will produce 3 more of hydroxide. That means the concentration of hydroxide will be triple the concentration of the iron 3 plus. Here then we have the KSP equal to 3, iron 3 plus concentration, and here also we need to square the stoichiometric coefficient, which is here 3. That means if the concentration of iron will be S, that means the concentration of hydroxide will be 3S, because we need to, here we have the 3 more of hydroxide, and here we have 1 more of iron. Yes, that's what I was saying. That means if you are replacing, you get the KSP is equal to S. Here we have the 3S. Then we get 27S4. Then the KSP, we have it. We replace the value of KSP that was given for ferric hydroxide. Then we determine the S. After determining the S, then we get the S is equal to the solubility equal to 1.39 times 10 power negative 10 molar. That means the S is equal to concentration of iron. Then to determine the concentration of hydroxide, we need to multiply by 3. So here we get the concentration of iron, which is equal to this one, and the concentration of hydroxide will be equal 3 times 1.39 times 10 power negative 10. Then we get this value of 4.16 times 10 power negative 10 molar. Let's go to mercurous iodide. Also, you can see that mercurous iodide will decompose by giving 2 moles of mercury and 2 moles of iodine. So here that means here we have 2S and here we have 2S. So then in this case, then you have the 2S, because here we have 2 moles which is produced with 2 moles which is produced. Here then you have 2S and 2S, and also you need, don't forget also to square the geometric coefficient. Then in this case we have the KSP is equal to 16S4, S power 4. Then we determine this S. So S, we get the value of S, we get 4.1 times 10 power negative 8 molar as S. Then we determine the concentration of the mercury, and the concentration of iodine will be equal to 2 times this solubility, because here this will produce 2 moles of mercury and 2 moles of iodine. And remember, we are determining the solubility of this one, this compound, that means the solubility of this compound is equal to 4.1 times 10 power negative 8 molar. But the solubility for 2 moles of mercury and 2 moles of iodine, we need to multiply it with by this solubility, because here upon decomposition we will produce 2 moles of mercury and 2 moles of iodine. Question number 5 is saying how many lead 2 plus and the iodate ion are present in 3.8 liter of saturated solution of lead iodate. The KSP was given, which is equal to 3.68 times 10 power negative 13. Here then, they are asking how many lead, how many ions, so in the of lead, and how many ions of iodate are present in the 3.8 liter of saturated solution of this one. So as long as we have the KSP, we can determine the solubility. The solubility will give us the mole per liter. How many mole are in 1 liter? Then we determine how many mole are in 3.8 liter. Upon getting the number of mole which are in 3.8 liter, then you are going to determine how many atoms or how many ions. This is how it will decompose. It will produce 2 moles of iodate. Then the KSP will be equal to S times 2S, because here we produce 2 moles. Then we get this one and we determine the S. So we get that the S is equal to 4.51 times 10 power negative 5 mole per liter. That means S will be equal to the lead. The concentration of lead will be equal to 4.51 times 10 power negative 5 mole per liter. But the concentration of iodine will be equal to the concentration of lead times 2. Then we will get 9.02 times 10 power negative 5 mole per liter. That means this one multiplied by 2, we get this one. After getting the moles which are in 1 liter, here we have also the moles which are in 1 liter. Then we determine how many mole are in 3.8 liter. Then for lead ion, we have this one mole in 1 liter. In 3.8 liter, we have this one times 3.8. Then we get this number of mole in 3.8 liter. Again, for iodate is the same. We have these moles in 1 liter. Then to obtain the moles in 3.8 liter, we multiply and then we get 3.43 times 10 power negative 4 mole in 3.8 liter. After getting the number of mole, how do you get the number of ions? Then we know 1 mole of ion is equal to the Avogadro's number ions. Then in this case, 1 mole of particular ion is equal to this number of ion. That is what means a mole. A mole is this number of atoms, or this number of ions, or this number of items. That's what you call a mole. Now, if you are having this number of mole, to obtain the number of ion, we multiply with this Avogadro's number. So in this case, this one, for lead, you have this number of mole. Then you will get this number of lead ions. Then for iodate, we have this number of mole. Then we multiply for Avogadro's number to obtain this number of ions for iodate ions. Question number 6 is saying 200 milliliter of this concentration for this chemical silver nitrate is mixed with 250 of this concentration of sodium iodide. They are saying what is the name and the mass of the precipitate. What is the name and the mass of the precipitate? Here we need to apply the solubility rule to know which one is the precipitate which is going to be formed. For example, like silver nitrate, which will react with sodium iodide, it will form silver iodine, which is a precipitate. Then this is not a precipitate because this one is soluble. If you go to the solubility rules, you will find that the silver compound are not so soluble. Then we need to determine the mole of silver nitrate. So we get this number of mole. We determine also the mole of sodium iodide. You also see this number of mole. Then in this case, if you have this number of mole, and they are reacting 1 mole here, and here they are reacting 1 mole, that means 1 should be the limiting reactant. The silver nitrate is the limiting reactant because it is less. So this silver nitrate will be the limiting reactant. We have 5 times 10 power negative 6 mole, and here we have 5 times 10 power negative 5 mole. That means silver nitrate is the limiting reactant because it is less. So here only the product, this one, the silver iodine, will be determine the amount of silver iodide that will be formed will depend on the silver nitrate, the limiting reactant. That means the moles of the silver iodide that will be formed will be equal to the moles of silver nitrate which is reacted. That means 5 times 10 power negative 6 mole of silver iodide is the one which are going to be formed. Then you have the molar mass, so that we get, if you have the molar mass and have the moles, you can get the mass of the precipitate, which is the form mass of the precipitate. Then we take the molar mass times the moles, then we get 1.19 milligram. Let's go to question 7. Question 7 is saying they are asking if a precipitate is going to form if 34 milliliter of lead nitrate are mixed with 79 milliliter of sodium iodate. The KSP of lead iodate was given as 3.668 times 10 power negative 13. Let's go to the answer. In this case, they are given the KSP of lead iodate. That means that's the product which is going to be formed from lead nitrate and sodium iodate. So first of all, we need to determine the mole of, because the solubility product is there. If we have the KSP of lead iodate, that means the KSP will be equal to the lead times the iodate. We need to find their concentration then after mixing. The mole of lead before mixing, that means we take here the mole of lead before mixing. We have 34 milliliter, and you have also the concentration. That means you take the concentration, multiply with the volume. Then also we determine the mole of iodate before mixing. Also the same, we take the concentration of this one, multiply with the volume, and the volume is 0.079. We change the volume in liter, and here for lead before, here also we take this one, multiply with 0.034. Here is multiplication, not just the division, so that should be here. Okay, then after also we determine the concentration of lead after mixing. If you are mixing, that means the volume will be total. So that means take the moles dividing with the total volume. Total volume, that means 79 plus 34. Then you obtain this one. You also determine the concentration of iodate after mixing. That means also we take the mole dividing with the total volume. Then we get this one. Then we determine the ionic product. So this is the lead iodide that will be going to be formed. So then this lead ionic product, that means we take lead times the concentration of iodide square, because this one will be having 2 moles of iodide. Then that means here we get 0.0, the concentration of iodine, the lead we have it. Then we need to, here we have the concentration of the iodine. We need to square it. This is here, the concentration of iodate, not iodine. 0.00224 molar. So that is where we are squaring, because here we have 2 moles of iodide that are going to be formed upon dissociation. Then times the concentration of lead. Then we will get this 1.3 times 10 power negative 8 mole. Then to know whether a precipitate is going to form, we need to compare this value with the KSP. So you can see that the value that we get, 1.3 times 10 power negative 8 molar, is higher than the KSP. So if it is higher than the KSP, that means a precipitate will form. So if the ionic product is higher than the given KSP, that means a precipitate is going to form. Let's see question number 8. Question number 8 is saying take a solution of lead nitrate and sodium sulphate. There are 2 solutions. Identify the ion that represent each solution and calculate their concentration. That means what is the concentration of lead and nitrate here, and here what is the concentration of sodium and sulphate. Give the chemical equation for the reaction between lead nitrate and sodium sulphate. We give the chemical reaction between the two. Then they are saying identify ion that are mostly susceptible to form precipitate when two solutions are mixed. Then they are saying if 1 liter of each solution are mixed with a precipitate to be formed and why KSP of lead sulfate was given. That means here we need to calculate the ionic product for lead sulfate and then you compare it with this KSP. If now the ionic product is higher than the KSP, a precipitate is going to form. Then to identify the ion that are mostly susceptible to form precipitate, we need to look what we call the solubility rules, where they are, some of the ion when they are combined with others, they give the insoluble or they are not soluble and they form the precipitate. So here we have lead nitrate, that means lead. That means the concentration of nitrate will be double the concentration of lead. That's what we want to do. So we have lead which equal 2 times 10 power negative 3. That means nitrate will have double the concentration of lead. Same as for sodium sulfate, that means sodium will be having double the concentration of the sulfate. So that is what here we have sodium concentration equal to 4 times 10 power negative 3, because the concentration of sulfate will be equal to the concentration of sodium sulfate. That means sulfate will have 2 times 10 power negative 3 molar. Then sodium will have double the concentration of the sulfate, because here we have 2 moles of sodium. Then after the reaction, that means the lead nitrate which will react with sodium sulfate, then we have lead sulfate plus 2 sodium nitrate, but this one is the one which will give the insoluble. So lead and sulfate are 2 ions which are forming the insoluble compound. So that means from the solubility rule you can see that the lead compound are insoluble. So then here we have the ion that are mostly susceptible to form the precipitate. Then after having the 2 ions, then you can calculate the ionic product by taking the concentration of lead times the concentration of sulfate. So these are quickly the solubility rule. You can read them. The solubility rule. So you can see that acetate, nitrate, and chlorate are soluble. Rule number 2. Rule number 1 is not formed by group 1 cation, and ammonia are soluble. These include the salt formed by these ions. Only the exception apply for lithium salt. Number 3, bromide, the chloride, and the iodide are soluble except silver, lead, and mercury. Silver compound are insoluble except for silver nitrate and silver acetate. Sulfate are soluble except for sulfate. For this one you can see this insoluble compound are coming. Hydroxide are insoluble except the alkali metals and the alkaline alpha metals. This one they are less soluble, slightly soluble. Sulfide are highly insoluble except alkali metals and the alkali alpha metals. These are the solubility rules. Then you check which compound are insoluble and which one are soluble depending on this rule, the solubility rule. Carbonate, chromate, phosphate, chloride are insoluble except for the alkali metals. So we have to know if the precipitate will form. We need to calculate the ionic product and then compare it with the given KSP. In some question, in some exercise, they don't give the KSP. If no KSP was given, you need to go to the internet and look in the table. Just a simple search might give you the table for the solubility product for different salt. Then you use that KSP that extracted from the internet. So that means to calculate the ionic product, we need to determine the concentration of each ion after mixing the 2 solutions. That means the total volume will be 2 liters, because they are asking if 1 liter of each compound is mixed with another liter. So that means here the volume will be 2 liters. So lead before mixing, then we get this one, number of mole. Also determine the mole of sulfate before mixing. Then we determine lead after mixing. That means it will be the total volume, which will be 2 liters. We determine also the sulfate. After mixing, you can see before there are moles of lead is equal to the mole of sulfate. Then Concentration of lead after mixing will be equal to the concentration of sulfate because the moles are equal and they are all in the total volume. Then you get this one. Then we calculate the ionic product by taking the concentration of lead times the concentration of sulfate. Then we get this one. We compare this ionic product with the KSP that was given. We see that the ionic product is higher than the KSP. In this case, the ionic product is higher than the KSP, therefore a precipitate will form.